There's going to be a large increase in jobs in biomedical engineering and in particular tissue engineering in the next 10 years, with over a 30% increase in jobs predicted as compared to general engineering jobs, which are expected to increase about 9%. And this is due to the aging population as well as the need for critical care devices that are cost effective and to produce as well as to use for the patients. And so the engineers are becoming more and more involved in the healthcare industry, and there's more and more demand for them. Biomedical engineering is very broad, and what we focus on here at Colorado State University are a couple of areas. One, my area in particular, is cell and tissue engineering. What that involves is long-term trying to develop tissues, maybe artificial organs, so you can develop an artificial pancreas, skin transplants, tissue-engineered arteries would be more my forte. Trying to develop these products so that they function well in humans for long periods of time. So the limitation right now is, yes, we can put a tissue together, we can put pancreas cells on a polymer and implant it in an animal right now, but the functionality of the tissue, it doesn't work very well right now. So we need to understand why it doesn't work. So part of what I focus on are the molecular events leading up to how the cells behave in a different environment and how we can tap into that to better engineer organs in the future. The very nature of biomedical engineering essentially necessitates collaborating with others. We need to understand molecular events, genetic events, all the way through to how a cell functions and then how that cell will function in a tissue, a three-dimensional tissue. What's holding the technology back is this molecular understanding of how a cell functions in different environments. And so where I see right now the hot area for this research is doing the interconnection between the molecular events that are occurring to the cellular, to the tissue level, and being able to pull this all together into an actual tissue-engineered organ. And so that's where the technology is going that allow us to actually get some of these devices and these products on the market so that we don't have to depend so strongly on our donors. This is a very exciting time to be involved in tissue engineering. My aspects of my projects, I'm involved with cardiovascular stent design, tissue-engineered heart valves. All this is great because it's so relevant to what we're going to be doing in the future, applicability to human health. You know, you can't have a bigger driving force than I might need this one day. So I've really enjoyed this field and the interaction with the other life scientists, the cell biologists, the clinicians. I've talked to people at the Health Sciences Center and are working with collaborations at the med school there. So this is just a great time to be involved in biomedical research.